When we did the salmon colored paper the other day on problem number 12, we could not find the answer by factoring. Some things do not factor. Some things do factor, but their numbers are really, really hard to work out. So there is another way that you can solve for x without factoring, and that's called the quadratic formula. I would have expected many of you to have heard of the quadratic formula previously. The quadratic formula is used to solve quadratic equations in standard form. So right here on your notes, please write the standard form of a quadratic equation on page 1 of your notes. This is what standard form looks like. Why am I calling it a quadratic equation? Usually we think of the prefix quad as meaning 4, but in this case it means 2. Quadratic equations are raised to the second power. X squared makes it a quadratic equation. And when we solve a quadratic equation, we will get 2 answers. And this is the formula that we're going to use to solve quadratic equations, but I can't really tell you where that formula comes from yet. I've got to teach you a couple more algebra skills, and then I'll show you how you get that equation. But for today, we're just going to use the equation. We're going to plug the numbers into the equation and solve for x. You do not have to memorize the equation. It will be given to you. But what does step number 1 say to solving a quadratic formula? It must be in what? Is problem number 1 in standard form? No. In standard form, it has to be equal to 0. Is this equal to 0? It is not, so I have to make it equal to 0. I have to make it equal to 0 by subtracting the 14 from both sides. Now, I really don't have a lot of room to work with, and so when you subtract 14 from both sides, it's going to make the 14 negative, and it's going to be equal to 0. So I kind of did a shortcut there. When you subtract 14 from both sides, the 14 will be negative and this side will zero out. Because in standard form, it has to be equal to 0. Now that it's in standard form, you can fill out this little chart. This little chart is, just like we did on the worksheet the other day, is to get everything organized so you can fill in the formula easier. So A is the number in front of the x squared. If there's not a number in front of the x squared, what could the A be? B is the number in front of the x. C is the number without an x. B squared means I take this number and square it. The 4AC, the 4 is from the formula, so you multiply the 4 times the A times the C. Two A would be 2 times 1. 2A would be just equal to the number 2. This little chart is just to help you get all of the pieces together so that you can fill in the formula easier. So x equals minus b plus or minus b squared minus 4ac, all of this part is under the radical sign, divided by the 2a. You do not have to write the formula down. You may write the formula down if it makes it easier for you to plug it in. Plug what in? So, in place of this minus is from the formula. In place of the b, I'm going to plug in the 5. Plus or minus. In place of the b squared, I'm going to plug in the 25. This minus is from the formula, and the 4ac is another minus 56. I will in the next step. And so this number right here is a 2. Okay, I got everything plugged in. When we have a test on this next Tuesday, you will not get any points if you cannot plug the numbers into the right place with the right sign. You are not required to memorize the formula, just be able to use the formula. So you've got to be able to plug the numbers in to the right place with the right sign. So then, the way this format is set up, I put a space over here for you to simplify the radical. What is a radical? So, you're a little bit behind here. So, what's a radical? A square root. And so, you are going to put the square root over here, and I gave you some space over here to simplify that radical. So right here is where I'm going to say, I know that minus a minus makes a plus. And I am going to add those together, and that will be 81. Now, I don't need a birthday cake like I was doing yesterday. For this one, the square root of 81 is 9. So, in place of this radical is equal to the number 9. I still have a minus 5 plus or minus the 2. That's what x is equal to. Now I guess we better talk about what this plus or minus thing means. This plus or minus thing is a way to write two answers. It's a shortcut way, so I don't have to write the numbers out twice. Because when I solve a quadratic equation, I'm going to get two answers over here. One of the answers is going to come from the plus, and one of the answers is going to come from the minus. At this point, I need to break it down. X equals negative 5 plus 9 divided by 2, and x also equals negative 5 minus 9 divided by 2. That's how you get the two answers out of that. You break the plus and minus apart into two separate answers. To get the correct answer with your calculator, you've got to put parentheses around this before you put it in your calculator. If you put it in your calculator without the parentheses, you will not get the correct answer. Or you can just figure it out in your head. Negative 5 plus 9 is a 4. 4 divided by 2 is 2. Negative 5 minus 9 is negative 14. Divided by 2, negative 7. Those are your two answers. It does not matter which one goes first. Also, on this particular problem, it probably could have been solved easier by factoring. This particular one could have been factored, but I chose this for your first example because we want to start off with an easy one and work up to the more difficult ones. The first thing you do on a problem is check and see that it is in standard form. Is it equal to 0? First thing you need to do is make sure it's in standard form. If it is in standard form, then you can fill in your A, your B, and your C. And then you need to fill in your b squared. Now we got to talk about b squared for a minute. What is b squared here? Negative 13 squared. If you put it in your calculator like that, the calculator will tell you that the answer is negative 169. The calculator is lying. It is lying because you put it in wrong. The correct way to put it in the calculator is like that. Or you can just know that negative times negative will always make a positive number. But I just want to warn you, if you put it in the calculator without the parentheses, it's going to give you the wrong answer. The calculator will lie to you about those squares. So I want you to write this on your paper. This number is 169, and the b squared will always be a positive number. The b squared is always going to be a positive number. The 4ac is going to be negative 120, and 2a is going to be 12. This chart is to figure out all the pieces so that you can plug them into the quadratic formula easier. The quadratic formula is minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So you plug in your b. This minus is from the formula. And then the b is minus 13. Plus or minus, b squared is always positive. This minus is from the formula. This minus is from the 120, all divided by 12. Over here, we're going to simplify that radical. 169 minus from the formula, another minus from the 120. Minus a minus makes a positive. No. Add those two together, and you get 289, the square root of 289. That's kind of a big number. The first thing you do is pick up your calculator and take the square root of 289 and see if it is a whole number. It is a whole number, so you don't have to do the birthday cake. Now, it is not the square root of 17. It is the whole number 17 because in your calculator you did the square root to the 289 number. The square root is not there anymore because you did that with your calculator. This number is equal to 17. This is minus from the formula. This is minus 13 from the b. Minus a minus makes a positive 13. And it's still divided by the 12. That is hiding two answers from you. The first answer is 13 plus 17 divided by 12, and the second answer is 13 minus 17 divided by 12. That's the meaning of plus and minus. You add the 17 and you also subtract the 17. If you add that together, you get 30 divided by 12. 13 subtract 17 is negative 4 divided by 12. There will be two answers. And what does this say right here? Reduced. We need to reduce these fractions, 30 over 12, to lowest terms. So, what's the GCF with 30 and 12? 6 is the GCF. If you divide it, they both divide by 3. If you divided by 3, you would have to divide again because that would not be completely reduced. But if you divide that by 6, you would get 5. If you divide that by 6, you get 2. What's the GCF between 4 and 12? 2 divides them, but 4 is the GCF. 4 divided by 4 is 1. 12 divided by 4 is 3. That is your reduced answer. Now, on the test coming up next Tuesday, the way I'm going to grade this, suppose this was a 10-point question. You would not get any points if you can't fill in the first step with the right numbers and the right signs. If you get this much, you would get 6 points. If you get the reducing right, you would get 2 more points. If you get the reducing the fractions right, you would get all the points. So, if you can't reduce the fractions, that's only going to be like missing 1 point. So don't get too concerned about missing the fractions or reducing the fractions. And so, before you can use the quadratic formula, it has to be in standard form. Is problem number 3 in standard form? What do I have to do to get it in standard form? And so this would be 36x squared minus 49 equals 0, because that would cancel out. So what's the A? And what's the B? And what's the C? Not 49, but negative 49. Be careful with the signs, because if you mess this sign up, possibly you would mess this sign up also. 0 times 0 is still 0. When you multiply this out, 4AC, you get... Now, it is totally and completely possible to work out the quadratic formula with a number that big. It's the exact same steps. But I think there's an easier way to work this problem. Instead of using the quadratic formula on this problem, I think it's easier to get the answer by factoring if you know the difference of two square pattern. So that's what I'm going to show you instead of the quadratic formula. The reason you can factor this easier than you can use the formula is because this is a perfect square number. What is the square root of 36? And what is the square root of 49? And you can use this pattern because B is 0 and C is negative, and these are perfect squares. If you have perfect squares and B is 0 and C is negative, it will factor like this. Where did I get the 6 and the 7? And this is plus and minus, so that when you did the box problem, those x terms would cancel out. Now this is not solved. This is factored. Solving means find the two answers. Now I'm not going to do this because I didn't do the quadratic formula. I'm not going to have a radical on this one. The zero product property tells me the first term equals 0 and or the second term equals 0. So all I have to do is solve those two small equations. On this one, what am I going to do with the 7? And so some people on the quiz the other day told me that the answer was 7. Well, it's not. What about the 6? What do you do with the 6? And so the answer is negative 7 over 6. And then on the second equation, add 7 to both sides. The answer is not 7. I still have a 6 there. What do you do with the 6? Cancel it. And I think on this particular problem, it's easier to factor it instead of using the quadratic formula. we'll get to that in just a second. We'll talk some more about simplifying radicals, I believe, on this next problem. On problem number 4, before you start the problem, you have to make sure it's in standard form. Is it in standard form? If the answer is yes, then you fill in your A's and your B's and your C's. And you continue down the chart. B squared 4AC and 2A. Once you have this chart filled in, the reason we fill in the chart is to make it easier for you to fill in the quadratic formula part, because now you have all the pieces. X equals minus B, plus or minus B squared minus the 4AC number, all divided by 2A. The reason I have this box over here is so that I can put the radical, square root, over here and simplify, have some space to simplify it. 25 minus 12, of course, is 13. 13 is not a perfect square number. If it's not a perfect square number, then you do the birthday cake on it. But the birthday cake's pretty short here. Because does it divide by 2 or 3 or 5? The only thing that divides it is 13. Are there any pairs? There are no pairs. So this is the reduced answer. It doesn't reduce anymore. So this is replaced by the square root of 13. I still have the negative 5 plus or minus. I still have the divided by 6. Now, I told you earlier that a quadratic always has 2 answers. Where are the 2 answers? The first answer is from the plus square root of 13. The second answer is from minus the square root of 13. You do not have to separate it out. I was just pointing out there still are 2 answers. It is perfectly acceptable to leave your answer in this form, or you can break it down into that form. Because this is the only one where that applies. In the previous problems, you did have to continue breaking them down because they would break down farther. The reason I don't have to continue on this one is because the square root of 13 does not reduce anymore. But that would not be acceptable on the previous problems. You did have to continue down to a whole number or a fraction answer. Now, what we're going to find out next week when we start graphing these are the x-intercepts. When you find the solutions, these solutions are the x-intercepts. Would these numbers be very easy to put on a graph? So when we get to the graphing part, we will decimalize these answers in order to put them on the graph. But for right now, we're just going to leave them in this form. So hopefully by now, you can fill in the chart and you can fill in the quadratic formula. Please do that right now. Did you get it filled in correctly that far? Once you get it filled in correctly that far, then you put the radical over here in the radical box, and you simplify it. Minus a minus makes a plus. And so then you add those together and you get 148. 148 is not a perfect square number. If it is not a perfect square number, that means birthday cake. How many times will 2 go into that? And 2 will go into 74. And 2 does not go into 37, and 3 does not go into 37, and 5, and 37 is a prime number. The only thing that divides 37 is 37. Why did I do the birthday cake? To find pairs. And so there's a pair of 2's and a 37, square root of 37. This is replaced with 2 square roots of 37. That is the reduced radical. Still have a negative 6, plus or minus, still have an 8 on the bottom. Now I have to reduce it a little bit more. The 37's not going to reduce. Even if the 37 was some number divisible by 8, it still would not reduce. But there is some reducing that I can do. Because this line that goes all the way across means that this number is divided by 8 and this number is divided by 8. In order to make it a little bit easier to reduce, I am going to separate it into 2 separate fractions because both of these numbers are divided by 8. Just makes it easier to reduce because now when I look at it, what's the GCF between 6 and 8? 2, this divides by 2, this divides by 2. This divides by 2, this divides by 2. And this is still the plus or minus sign in between there. That is the reduced answer. If the reduced answer is what's confusing you, once again, if you can get it that far, you will get most of the points on the test on Thursday. So, there are 2 answers represented by the plus and minus, but you don't have to break it down into 2 separate reduced answers if this is a radical here. No. That's as far as you can go. The only other thing you could do is decimalize it if you wanted an approximate answer. But we want to leave it in an exact answer. Okay, see how far you can get on problem number 6, please. Did you get that far correctly? If you can get in the chart filled in, if you can get the formula filled in on the test next Tuesday, you will get most of the points. So you fill in the chart, put down on your chart for you to remind you the b squared is always a positive number. You fill in the formula and then you simplify the radical. 4 minus a minus 20. This minus is from the formula. This minus is from the 4AC. Minus a minus makes a plus. That would be 24. Is the square root of 24 a perfect square number? It is not, so that means birthday cake. Divide by 2 as long as you possibly can, then divide by 3. The reason you do the birthday cake is to find the pairs. This doesn't have a pair, this doesn't have a pair, they multiply together. This reduces to 2 square roots of 6. Minus a minus makes this 2 positive, and it's all divided by 10. If you can get that far, you will get most of the problems on the test, but it will reduce a little bit farther. It will reduce a little bit farther because 2 divides by 10. this number divides by 10 and that number divides by 10, so I can separate it into two separate fractions to make it a little bit easier to reduce. The GCF between 2 and 10 is 2. 2 goes into 2 one time, 2 goes into 10 5 times. The GCF between 2 and 10 is 2. That divides by 2. That divides by 2. That's the reduced solution.